Hello everyone, my name is Dr. Sauramani Tripathi and you are watching my YouTube channel EE Lectures. Through this video, I will clarify the answers to a few multiple choice questions related to the DC machines. So let us look at the first question. A 4-pole lap-wound DC shunt generator has an armature winding consisting of 200 turns, each of 0.004 ohms. The armature resistance is, the options are 0.2 ohm, 0.8 ohm, 0.05 ohm, 0.1 ohm. Before I explain the answer to a question, I suggest you to get the video paused and find the answer by yourself. Once you find the answer by yourself, replay the video and match your answer with the correct one, which I will let you know with an explanation. Here we have total number of turns is equal to 200 and resistance of each turn is equal to 0.004 ohm. Therefore, total resistance of 200 turns will be 200 multiplied by 0.004, which is equal to 0.8 ohm. Since the machine is lap wound, the number of parallel paths will equal to the number of machine poles. Therefore, A is equal to 4. Now we may calculate the resistance of each parallel path by dividing the total resistance of 200 turns by number of parallel paths. This comes out to be 0.2 ohm. Now the armature resistance will be nothing but the equivalent resistance of all 4 parallel paths, which is calculated as 0.05 ohm. So the third option is the correct answer. Next question is, in a shunt DC generator, the electrical efficiency will be. The options are electrical power developed in the armature over input mechanical power, net output electrical power over input mechanical power, net output electrical power over electrical power developed in the armature, electrical power developed in the armature over net electrical power. Recall, we may define the electrical efficiency of the DC generator as net output electrical power over net output electrical power plus electrical losses. Here, the term net output electrical power plus electrical losses is nothing but the electrical power developed in the armature. Therefore, the electrical efficiency of the DC generator can be written as net output electrical power over electrical power developed in the armature. So, the third option is the correct answer. Next question is, the commutator pitch for a simplex lap winding is equal to. The options are number of poles of the machine, number of pole pairs, 0, 1. The commutator pitch is defined as the distance between the commutator segments to which the two ends of a coil are connected. As can be seen in this figure, the commutator pitch for a simplex lap winding is equal to 1. So, the last option is the correct answer. Next question is, the back EMF of a DC motor at the time of starting is. The options are 0, maximum, minimum, half of the applied voltage. Now recall the back EMF equation of the DC motor, from which we can easily conclude that the back EMF of a DC motor at the time of starting will be 0. So, the first option is the correct answer. Next question is, maximum mechanical power is developed in a DC motor when applied voltage is equal to. The options are half of the back EMF, double of the back EMF, square root of the back EMF. As we know, the mechanical power developed by the DC motor would be the maximum when the back EMF EB is equal to half of the voltage applied across the armature ends. This equation may also be stated as maximum mechanical power is developed in a DC motor when applied voltage is equal to double of the back EMF. So, the second option is the correct answer. Next question is, the back EMF of a DC shunt motor does not depend on. The options are number of armature conductors, field flux, armature speed, insulation class. Recall the back EMF equation of the DC motor, from which we may easily conclude that the back EMF of a DC motor depends on all three factors, that is field flux, number of armature conductors and armature speed. It however does not depend on the insulation class. So the last option is the correct answer. Next question is, in a DC series motor the field flux is, the options are nearly constant, proportional to the armature current, inversely proportional to the armature current, proportional to the square of the armature current. Actually, in a DC series motor, the current equal to the armature current flows through the series field winding. Clearly, the field flux is proportional to the armature current. So, the second option is the correct answer. Next question is, if there are 20 coils in the armature of a 4-pole DC machine, then the total number of armature slots will be, the options are 10, 20, 40, 80. Recall that the total number of armature slots required is essentially equal to the number of coils in the armature. Since there are 20 coils in the armature of a 4-pole DC machine, then the total number of armature slots would also be 20. So, the second option is the correct answer. Next question is, if there are 30 armature slots in the armature of a 6-pole DC machine, then the pole pitch in terms of armature slots will be, the options are 3, 5, 6, 10. The pole pitch can be calculated by dividing the total number of armature slots with number of machine poles. Since there are 30 armature slots and number of machine poles is 6, thus the pole pitch will be 30 divided by 6. So the second option is the correct answer. Now, the last question is, a 4-pole lap connected DC machine has an armature resistance of 0.2 ohm. What will be the armature resistance of the DC machine if it is rewound for wave connection? The options are 0.1 ohm, 0.2 ohm, 0.8 ohm, 1.6 ohm. Since the machine is lap wound, the number of parallel paths will equal to the number of machine poles. Therefore, A is equal to 4. Here, we have the armature resistance is equal to 0.2 ohm. Actually, the armature resistance is nothing but the equivalent resistance of all parallel paths. So, considering R is the resistance of each parallel path, we may write the equivalent resistance of all parallel paths equal to 0.2 ohm. Thus, R is calculated as 0.8 ohm. Now, when the machine is rewound for wave connection, the number of parallel paths will be only 2. In this case, the resistance of each parallel path will be equal to 2R. Therefore, we may calculate the armature resistance for wave wound machine equal to 0.8 ohm. Hence, the third option is the correct answer. That's it for now. Thanks for watching. Goodbye.